Hello, welcome to creating your first ERC-20 token. We are making a crypto token. I'm going to show you every step of the way. We're even going to build a simple front-end wallet, emphasis on simple, but I'm going to show you every single step of the way. This ERC-20 that we're going to make is fully customizable. We're going to do just the bare bones right now. Later in another video, we can actually think about how to make the token work with whatever kind of customization that you want to do. Let's get right into it. What is an ERC-20 token? An ERC-20 token, it's going to be built on the Ethereum blockchain, and it adheres to specifications. Let's go to the OpenZeppelin GitHub, and right here, OpenZeppelin ERC-20 interface, ERC-20. What this is, this contract simply defines the function names, the inputs, and the returns. So it's really just the data type of the input and the data type of the return. And as long as you inherit or build a contract that has these functions named this way with these input data types and return data types, then you will have a valid ERC-20 token, and it can interact in the marketplace like any other ERC token. Wallets, exchanges, smart contracts, everything knows how to deal with your token in a specific way because every token has the same base functionality. So every token is going to have a total supply that you can return. It's going to have a function where you can check the balance of an address, so you could input your address into this function and it returns the balance. Granted, these are not defined yet. This is just the specification of what your functions have to be named and what they return in intake. It's up to you to decide how you actually implement these. So you can think of whatever you want. There's a transfer function where it takes the recipient and the amount you want to transfer. There's an allowance function, so you can you, the owner, can specify someone as like being a spender of your coins. Approve, similar to allowance, I think. Transfer from, same thing. Sender, recipient, amount. If you own the tokens, we're not actually going to do anything with the allowances, approvals, and transfer froms. But then there's another. The transfer function itself is what we mostly will use with our wallet. And then we have events. Every token, when it's transferred, emits the transfer event and then an approval event. And so this way you can keep a cache of all historical transfers. All right, so every coin that's in ERC-20 has to have these functions. What OpenZeppelin did is they created their base ERC-20, and you see here it imports that file, the IERC-20, and then contract ERC-20 it inherits from that as well. The context, don't worry about the context or the metadata. Those are just a couple lines. You can explore them on yourself, but they don't have any real chain. They're not material to what we're talking about. So OpenZeppelin's contract has a balances, which is a mapping. So this takes every address and points to an integer, and that's that address's balance. Then you have allowances, which is the same thing in a way that you have an address that can have multiple addresses that can have allowances. We're not going to worry about allowances right now. And then we've got a data type integer total supply, so the total supply currently of your coin. And then we've got a string name and symbol. And those contracts, you'll see we can call the name and the symbol of the token so that our wallet can dynamically display different tokens. The constructor, you input the name and the symbol when you construct your token. As you'll notice here, when you construct the token, it does not create any supply or allocate the supply anywhere. That is up to how you implement your specific constructor or how you implement your minting functions. It's got a name, so you can call the name of the contract, returns the name, call the symbol, returns the symbol. You'll see those in the wallet, how you can dynamically call these from contracts. Decimals, so just like in Bitcoin and Ethereum, in the code, all the amounts are represented as Satoshis, or in Ethereum way, and you can tell the front end how many decimal places that is. So like 1 Satoshi is 1/100 millionth of 1 Bitcoin, and so that's where the 18 decimals comes in place. And we can override this if we want to have something simpler, which we will do. Total supply, so this returns that variable total supply. Balance of, this is where you check your mapping of addresses and balances, so you can get the balance of any address. And that's really all an ERC-20 is. It's just that really what the ERC-20 is this data structure right here. It's simply every account has a balance associated with it, and it's up to your contract to keep track of those balances. But that's your actual ERC-20 lives, all pretty much in this in this data structure right here. And then the transfer function, we're not going to go deep into these, obviously. They just take too much time, because we're really going for end-to-end right now, full hello world status. So you can transfer from recipient. You can give the recipient a certain amount. You have to be the owner. You'll see in the transfer private function or internal function here, the message sender has to be the owner of the coins. And then there's allowance function, approve, we're not going to worry about those. The transfer from, we're not going to worry about that. Increase allowance, decrease allowance. Transfer, here's the internal function. So the sender recipient amount, require sender's not the 0 address, require the recipient's not the 0 address. And then you do have to require that the sender balance is greater than or equal to the amount, and then it will subtract the sender balance, and then it'll add to the recipient balance. And again, you see here, it's all in that balances data structure. So that mapping of addresses to integers of amounts of the token. That's what basically it all lives in. This is your mint function, so you can create tokens out of thin air. It's up to you to decide how you want to implement this. This is internal, so this mint function right now can only be called from somewhere else in the contract. And if you notice, we haven't called this yet. So in the contract that inherits from this contract, we'll specify where we want the minting to happen. And then there's a burn. We can burn coins. Approve, more allowance approval stuff, and then some hooks that I'm not going to go into before token transfer, after token transfer. You see they don't actually do anything. These are this is for other stuff. So this is OpenZeppelin's contract. This is OpenZeppelin's interpretation of the ERC-20. You can do whatever you want with, again, the base. You notice you just have to have these ones, the transfer, balance of, total supply, allowance, etc., to be an ERC-20. So OpenZeppelin inherits from that. They define the balance of the transfer functions. And then what we can do is in our own contract, we can inherit that ERC-20. We call it simple token is an ERC-20. And then we're going to have a mint here, and we're going to override the decimal function. So that just for purposes of today, it's kind of simple to see the volumes, to see the amounts. So in our constructor, we're going to tell it, our token is called simple token, and the symbol is a ST for simple token. And we're going to mint. We're going to mint the initial supply all to myself. Which, why would anyone do that? It's not decentralized. So this is just simple for right now to learn the steps, but this is a useless token, obviously, and it brings no value to the world. And I'm going to mint myself the total supply. So nothing really interesting here, but I digress. So what we're going to do, we have constructed our contract. It's inheriting from ERC-20. Let's compile it. Good, compile tab. Let's go down to the deploy. I'm going to run this on my local Ganache chain. Let's pull up Ganache so you can see it. So Ganache I'm in command line. You get Ganache on your machine, and then you run Ganache-CLI. That spins up a local chain. I have told Remix right here to connect to my Web3 provider. So it knows to look at my custom network. It found it. It found my 10 fake accounts with 100 fake Ether each. And I can select my simple token contract, and I can hit deploy right here. And then in a second, we will see the deploy. Oh, I didn't hit an initial supply. Let's go 100,000, 10,000, 100,000, a million. Let's hit deploy. So now 1 million tokens were just sent to my deploying address, 0xA67. Now we have our simple token down here. So we can see these are all our functions and our data types. We can get our name, simple token, symbol, ST. Let's get total supply, good. And then balance of, let's do the balance of my address. Copy my address here. Then let's input it into, I probably don't want all that showing. So input my address into balance of, click balance of, and look at that, the total supply. And we can even do a transfer here. But let's do the transfer in the transfer is going to work just how you expect it to. Let's do the transfer in the front end. That will be much more interesting. So that's it. That is your first ERC-20 token. You've made a crypto token. Great job. It doesn't do anything, but this is just a learning step. So let's make the front end. Let's make that wallet. Let's make this so that you can actually interact with your token somewhere other than Remix. So our desired end state. Did we already go over desired end state? Connecting wallet. Oh, I don't think we did. So simple token ERC-20 wallet. It pulled the name from the contract. So we got my current address that's connected. While it's connected, I just press that. Simple token balance. Oh, this is an old. This is looking at the old contract. We can do a receiver address, and we can send tokens. And then if you look here, MetaMask, actually, this is really cool. Let's move myself. Oops. So MetaMask actually, because it adheres to the ERC-20 standards, I did some test transactions, assets. It actually knows, because it's an ERC-20, MetaMask can just get the information it needs and display this as an asset for you. So I can send, it's got a history of sends. Much cooler than the wallet we're going to create. Okay, let's create the wallet. That's probably what you're here for anyway. First step, close out our current wallet. Back out. Okay, so we're going to do an NPX. We're going to create this wallet. We're going to do NPX, create React app. Let's call it Simple Wallet 1. I'm going to fast forward through this part. Okay, now that we have create React app with Simple Wallet 1, we can do cd Simple Wallet 1. So now we're inside the newly created directory. The only library we need is npm install ethers. Hit enter. I'm going to wait for this to spin up. We have npm install ethers is now done. Now we can do npm start, and we can see what React gives us out of the box. Now it should load here. Okay, good. This is what React gives us. We really don't want any of this. But let's go into it. Simple Wallet 1, source. Let's go app.js. We're going to get rid of all of this. Just keep just the div right here. And now we're going to really abuse React here. We're really not using it in the best way, but this is just for quick and dirty to show you how we can do stuff. So we're going to create a wallet mod component, we're going to import from wallet.js, and then we will put our wallet here. And this is it for app.js. Yeah, this is it for app.js. So we're going to save this, fail to compile because there is no wallet.js yet. So now we can do new file. We're going to go const wallet, export default wallet. Okay, now let's save this, simple token, source, wallet.js. Interesting that you couldn't find wallet when we just made it, and it's in there. Maybe because we didn't have a return statement. Let's give it the old div. I don't know if that'll make it happy. Looks like it made it happy. Okay, so empty wallet. What are we going to put in our wallet? We're going to cram it full of a bunch of stuff that we probably shouldn't, but again, we're using React today. Let's import. I'm gonna copy and paste a whole bunch of stuff over. You don't have to see me type. I can explain it all. All right, so we're going to import React, use state, use effect. You'll see how we use those. Ethers is that npm install ethers library. Our styling is we make a CSS folder called wallet.module.css, and then we import it this way, and then you'll see how we style components. How we'll style a component is we'll say class name equals, and then curly brackets, and we'll do styles dot my class name CSS. How, whatever your class name is in CSS, this is where you put it. And your styles will act just like you would expect styles to work with a CSS JavaScript file, HTML JavaScript file. This is just my current favorite way to style. So that's how styles work. We're going to get the simple token ABI, and then we're going to have another module called interactions. I know there's a lot of like boring boilerplate stuff, but let's just make the interactions right now so it won't crap out on us. And let's go ahead and just copy this. I know, it's not, shouldn't be doing all this. Interactions. Interactions will be where we actually transfer coins. Interactions. We're still going to use CSS. I'm going to use the same CSS folder for the whole project because it's just a couple stylings. We're not going to go through the CSS, so just go get my file off the GitHub. Okay, interactions. We can save this as interactions.js in source. Interactions.js. No errors. Good, just what we expect. So let's get back to that wallet and let's actually build this out. What are we going to do first? We want to connect. So we're going to have a button. In our return statement. Let's give it a title. Let's just say H2. We're going to say token name, because we're going to actually create a dynamically displayed token name. Plus, so it's going to be token name ERC-20 wallet. So that's our title. So for that token name, we need to have a variable. So we're going to say const token name set token name equals use state token. So what this means is we have a variable called token name. It's going to contain the first value is going to be token. If we want to change the token name, we will use set token name. So if we want to change the token name, we will say set token name, new token name here. And then this will get updated with the new token name. A little React hook magic. So now we've got a token name, but its first value will be token, so it'll really just say token ERC-20 wallet. Now let's create a button to connect. So we're going to create a button. I do have a class name in my styles called button6, just a certain style I found that I didn't absolutely hate, and it went okay. So on click, when we click this button, we want a function to connect the wallet. Let's call it connect wallet handler. And then inside the connect button, we want dynamically just rendered text. So we're going to create another variable. We're going to call it con button text. And that will be the end of our button. So that con button text, we need to create that variable. So let's go to const con button text set con button text equals use state. The first value that we want our button to have is going to be connect wallet. We want it to ask the user to connect. Once the wallet is connected, we'll change this text dynamically using set con button text to say wallet connected. Right now, though, it's going to ask the user to connect the wallet. Everything will work except for I don't have my styles yet. So let's just save this, and then interesting that it's not giving us an error on the styles, but whatever. I'm gonna go grab my styles, simple token wallet, source. So just do this from GitHub, grab the styles. Where's copy? Where's copy? Copy, simple wallet 1, let's go source, let's paste this in there, wallet module.css, okay, great. Oh yeah, there's no ABI. So let's go to Remix. Let's go to our Compile tab. Grab the ABI right here. Now let's go back to Sublime. Let's open up a new file. Paste our ABI in. Huge long ABI, great. Let's save it. It's going to be source. We're going to do a new file. We're going to call it contracts. Create, and then we're going to say this is the simple token ABI.json. Okay, we don't need that anymore. Good, contract simple token ABI.json. Okay, so no more errors. Nope, connect wallet handler. Great. So we have our function connect wallet handler. What's it going to do? Let's tell it what to do. Const connect wallet handler. So what are we going to do when we press the button? First thing we're going to do is we're going to check if window.ethereum, and you don't have to do this, but I'm just going to do window ethereum.is MetaMask because I'm specifically kind of building this with MetaMask in mind. I don't really know what to do if it's not MetaMask yet, so let's just check make sure that Ethereum is in the browser and that it's a MetaMask. If not, then we can do, so else, if it's not MetaMask or Ethereum, do else, log need to install MetaMask, and then we can do set error message. Oh, we don't have an error message yet. I'm going to have an error message render on the screen at some point, maybe, but let's call it error message, set error message equals use state null for now. Set error message, please install MetaMask. Okay, so please install MetaMask will show up on the screen because down here at the bottom of our return statement, let's go ahead and just render error message. So if there's ever any text in error message, it'll be rendered on screen and it will dynamically update when we change set error message. Okay, let's assume the user has Ethereum. Now we can do window.ethereum.request method ETH request accounts. Now this is going to return a promise. Oh, my computer froze. Now this returns a promise. So what that means is, if you notice, at the end of that parenthesis, I'm going to do then. And that will take the result of the promise, and we can do something with the result of that promise. We could also do this as a async await. I'm actually going to use both because I like to make sure I remember how to use both, and so I inappropriately mix the two. So dot then, now the result from this, now we can do something with that result. What we're going to do is essentially result 0, the first, it can be an array of accounts. Result 0 is the first connected account. And so we're going to do something with that. What we're going to do with it is, let's have a function. We'll call it account changed handler. We'll pass in our account. Let's also have set con button text. And now we've gotten the accounts and we have a result. We're not doing a whole bunch of error checking, obviously, but let's say it's all gone successfully. Now we can set the connection button text to wallet connected. Then we can also do catch. So again, this is kind of a string of actions on this original promise. There's a then result, but we can also do a catch. This is our error checking. So let's do catch. Let's do error. Call it error, whatever it catches, and we'll just let's set the error message so we see it on screen. Set error message error dot message. So the error, the message is attached to the error. So this is, oh yeah, account changed handler. We don't have that function built yet. Let's do const account changed handler. It's going to take in the new address, and we'll do something with it, but let's just see. Yep, purchase. Cannot find simple token ABI.json. Okay, so great. We have our connect wallet. Let's see if, oh yeah, I'm already connected. So that worked actually. So account changed handler, let's get our balance. Let's get our account up on screen. So below the button, let's have a div class name equals styles.wallet card. So this is going to be our wallet card. Okay, within the wallet card, let's have H3, let's say, this is going to display our address. So we're going to save our address in default account variable. Close our div. Let's do another div for our user balance. So let's go, let's dynamically set the token name. So token name, balance, and then we'll have a balance variable that'll display. Close our div. Okay, that's good for right now. So we need a default account and balance. So let's set those variables. Const default account, set default account. This is where we'll store our address that's connected. Use state null, and then let's go balance and set balance. This will be our token balance. Again, let's initialize that as null. Okay, now we have an address and a token name. So when we get our account changed handler, when we get a new address, let's use this opportunity to set default account to the new address. So now it can dynamically render. You don't like what I did. closing div, closing div. We've got some kind of div issue here, I guarantee. I just think I did too many. I think I did one too many divs. So we've got first div, outer div, second div, that's the error. Okay. So this needs to close out. Now we should see, great. So this is my wallet card styling. Beautiful, isn't it? And then we hit wallet connect and it gives us our connected MetaMask account. No token balance yet. We need to do a whole bunch of contract stuff for that. So, but as you can see, that's a simple MetaMask wallet connection right there. Account changed handler. So now what we need to do is when we get a new account, let's have a function called update ethers. And this will be, update ethers is where we will have all of our contract, we'll have it create the contract instance. So let's say update ethers. And what are we going to do in update ethers? A whole bunch of stuff. So we're going to do a kind of a string of things here. We're going to call temp provider equals new ethers providers web dot web 3 provider window dot Ethereum. Creating. So the way Ethers does it is they have providers, signers, and contracts. The provider is just like your MetaMask account. A provider is read-only. Think of it as read-only. From the read-only provider, we can do a temp signer equals temp provider dot signer, get signer. Now, the signer is read-write. So now you can write. So you can do contract interactions. Then we can do temp contract. Temp contract equals new ethers.contract. So this is where we input the contract address, the simple token ABI, and then the temp signer. So now, so we get the read access, then we get the write access, then we get the contract built in with the write access. Contract is built using the address, the ABI, and the signer. So now our contract object that we're going to have, we can call all the interactions on it on behalf of the user, and they will approve interactions using their MetaMask. And it's just using the provider, signer, and contract. Now, the only way I really know how to do this in React is to have these, build these in a chain here, and then we can store them as variables using the useState. So let's do const. First, actually, let's get our contract address. And that's going to be we don't need to update that. So that'll just be a const contract address equals. Now we go to remix, go to deployed contracts. It's right here. Grab the contract address, go back to Sublime, put that contract address in. I'm going to tell myself Ganache CLI address. So it's my Ganache chain address here. Now we're going to do const provider, set provider equals useState null, and then we're going to do a signer. So that we can have these persist across component renderings, and then the contract object, set contract. All right, so now we just do the set provider, set signer, and set contract. So we'll do that down here. we'll do set provider equals temp provider. Let's do set signer equals temp signer, and set contract equals temp contract. Is that all we want? How to update ethers? Yes, it is. Okay. So now we will have our contract object. That's going to be the most important thing. That's how we can get the current user's balance, because we can call contract dot balance of, put our default account in there, and it'll return our current token balance. Okay, what is our functionality so far? I don't even think I saved this. Yes, I did. Okay, still connecting. All right, we want that token balance. Let's get the token balance. So what happens, let's say, update balance. Let's say every time the contract is updated, as in every time there's a new signer, we're going to repull the contract because you have a new address. So we could do this in new address, but either way, let's use effect for fun. So let's say use effect so use effect will, this little block of code will run every time the component renders, and then, well, the first time it renders, and then anytime whatever we put inside these square brackets is updated. So let's say anytime the contract object is updated or changed, we want to rerun this. Now I'm also going to check really quick before I run anything. I'm going to say if the contract is not null, then let's actually run the logic. So if the contract is not null, let's update the balance, and then let's update token names. So what are we going to do? Update balance, update balance. We're going to get the contract. We have it. We have the contract. This one will be fun and do async await pattern. I know we're mixing. Okay, so we're going to update the balance. So let's go get, we're going to do contract dot balance of default account. So if you remember, balance of is a function on our contract, and then default account is our connected account. So we're going to get the balance of. Remember, we have a function in our contract that tells us the balance of an address. So let's save this. Let's say this is going to return a big number. We have to convert the big number to something that's usable on screen. So we're going to say let balance big N equals await. So await the result of this promise, because this will be a promise, and it'll be saved as balance big N. We have to convert the big N to a number. So let's say let balance number equals balance big N dot to number. So convert it to a number. Now I happen to know that most numbers might get converted to scientific notation. So I am going to do something to get rid of that scientific notation, but actually not yet. Let's do, let's get the token decimals, because remember, this would essentially return the amount of satoshis, or the amount of whey, but we want the actual like display balance. So that is going to be, let's do get, we're going to call it let decimals equals contract dot get decimals, because we have a or it's actually not get decimals, it's just simply decimals, returns the amount of decimals. Then we can do let token balance equals balance number divided by math.pow 10 token, wait, no, decimals. So this will actually, this token balance will now be, it'll have the right decimal points. Now, if we get into a situation, so we're going to set the balance. So set balance to token balance. However, this might return scientific notation. If it does, you'll see in the code I have a function to convert this to out of scientific notation, but I think because we only have 2 decimal points, it's not going to be an issue for us right now. But when I was doing this before, it was. But you'll see in the GitHub code, there's a function to take care of this, but we don't have to go over that right now. Okay, so now we've set our balance, so that means our balance here should dynamically update. Oh, our token name. Let's set the token name. So update token name. Update token name. Let's do async await on this too. Async. So that means that we can do let token. Actually, I think we can just do set token name. Await the result of contract dot. What are we calling? I have it here. Name. It's just name. Contract dot name. Now our token name. So our token name, balance are all dynamically updated. Let's save this. Connect wallet. Not a number. That's why. Contract decimals is a promise event. Contract decimals is a promise event, and I forgot to await for the result of that before dividing. So save, boom, boom, connect wallet, good. 10,000 of the actual units. So we've got great, we have our connected wallet, we've got the connected address, we have our simple token balance. You see here the simple token dynamically updated to the actual token name itself. Let's now we can do interactions. Yes, we're ready for interactions. So let's add in our interactions component. Trying to decide where to put it. Let's move our error message up. Message. Okay. Now let's put our interactions. Interactions. We're going to say contract equals contract. So we're going to pass in the contract. And just with this contract object, because it has a signer on it already, we can do all our interactions without reinitializing all this Ethers stuff. You'll see it's going to be really cool. Just the same way we call all the functions here, we're just going to do it on the props. So interactions props. So let's say that. Let's go to interactions. We need it to accept the props now because we're going to have props.contract. We still look good. Yep. Okay. So now we're in the interactions. This is where this is going to be where we are going to move tokens around. So let's say our interactions. Let's say we're going to have a class name, styles.interactions, lowercase I, interactions card. Let's do a form. Let's say on submit the form. This is going to be where we're going to take the recipient address and the amount to be transferred. So form on submit, it's going to be, what do we call it? Transfer handler. Transfer handler. And I'm gonna cheat here. Copy and paste because you don't need to see me try to hack away at a bunch of HTML. Okay, so form on submit transfer handler. We'll have a function. So it's going to tell the user, hey, transfer coins. Receiver address, input type text, ID, receiver address, class name, style, address input. Send amount, it's a number input, minimum 0, step it's an integer, accepting integers. We actually can remove integers since we have decimal places in our coin. And then a button to submit, styles button 6, send. And then we're going to have a transfer hash that will come out of this send function, or out of the transfer handler function. So what do we need? We need a transfer handler, const transfer handler. This is going to receive the event. So e.prevent default to prevent us from reloading the page. I think we're probably going to do some async stuff in here. So transfer handler, we're going to do let the transfer amount equals e.target dot, see here, send amount. So send amount dot value. Then let's do let receiver address equals target dot receiver address dot value. So we've got the amount to be sent and we've got the recipient address. Now we can basically do contract dot transfer, and then it receives the receiver address and the transfer amount. And with this, MetaMask will ask the user, hey, do you really want to send this amount to this receiver? They'll say yes. That will return, this is a promise event, so this will return a transaction. So await for the promise event to finish. We now have a transaction text. Let's display the hash, the transfer hash. So let's say we now can do set transfer hash to text.hash. Now we need to just do a const, define our transfer hash, set transfer hash, use state null for the moment. And now when we do have a transfer hash, it will be updated and then rendered. And I believe that's it. Contract is not defined. Of course it's not, because it is in the props. It's props.contract. So we can do connect wallet. We've got a whole bunch of coins. We've got this address. Let's send to this address, and let's send a whole bunch. Hit send. To recap, we have our form, which is this. We've got receiver address, send amount, and send button. So we've got receiver address, input is text, ID is receiver address, send amount, input type number, ID is send amount, button type submit, and that's the send button, and then the transfer hash is displayed below. So in our transfer handler, which is on the on submit of the form, we have prevent default, prevents page reloading, and then let transfer amount equals the send amount, the receiver address, e.target, and then we do await props.contract.transfer to the address, the transfer amount, and then we can set our transfer hash to the hash so that when it's on a public chain, you can go look up your hash. So let's see this in action. Connect wallet, that's our current balance. Let's send a whole bunch to the other address. Now you see we're going to send 1,000 simple tokens. Do confirm. Great. And then in a second, this should be 8,999. No. Yeah. Great. So now we see an updated balance. And that's it. That is the simplest token wallet front to back, step to step. Thank you. Don't forget to like and subscribe. Next time I'm going to do a collectible fungible token. So we'll see how we can mess around with the ERC-20 contract itself to make our token more interesting.